I'm going to skip all the way down to number 4 because the first 3 are much easier. Remember, the process of this is always the same. We always are going to start with the ones place and then just move across going to the left. So you can think about, we're not even looking at this right now, so you can think about kind of getting rid of that if you want to. And then you just go ones place to ones place, which is 12. 6 times 5 is 30. Add that 1 is, and some people do it where they put the 3 first, 31. 6 times 8 is 48, plus 3 is 51. So now we're done with that. And I'm going to switch colors. Actually, first I need to erase what I did there, and I'm going to erase those so those don't confuse me. And I'm going to switch colors because now I'm done with this. So I'm going to add in my 0 as a placeholder. And now I have 5 times 2 is 10. 5 times 5 is 25, plus that 1 is 26. 5 times 8 is 40, plus 2 is 42. And again, we're making sure our numbers are lined up nice and neatly. Then when I add them together, I just add straight down, obviously. Count 3, and my answer is 47,712. If you are one who likes to do the lattice method, because we have a 3-digit number, we're going to make 3 columns by a 2-digit number, which means we make 2 rows. And then we have 852 times 56. And then we're going to draw in the lattice part, the diagonals. And we say 2 times 5 is 10. 2 times 6 is 12. Now we're going over to this, and we have 5 times 5 is 25, and 5 times 6 is 30. Now we're done with those. We're going to the 8. 8 times 5 is 40, and 8 times 6 is 48. Now we're going to add along the diagonals. So we have 2, 1, 1 plus 5 is 6, plus 3 is 9, plus 8 is 17, 3 and 7, and the answer that we get is exactly the same. We have to add in that comma, and really we should rewrite it so that our teacher doesn't have to try to figure out which numbers we're looking at there. Let's look at number 7 now. Again, just because it's 3 digits, nothing is different. We are going to, once again, I'm going to forget about these for now. And I'm going to say 2 times 3 is 6. 9 times 3 is 27. 5 times 3 is 15, plus 2 is 7. Now, just because I don't want to get confused, I'm going to erase those. I'm still not dealing with this place. I'm done with the ones place, so I'm going to add in my 0 as a placeholder because now remember it's the same thing as multiplying by 10, or in this case 40. 4 times 2 is 8. 4 times 9 is 36. 5 times 4 is 20, plus 3 is 23. Again, all lined up nice and neatly. I'm going to erase so I don't get confused. I'm going to change colors. Now, we're done with the ones place and we're done with the tens place. So we have to put a placeholder for both of those, for the ones and for the tens. And now I'm multiplying by 6. So I have 12. 6 times 9 is 54, plus 1 is 55. 6 times 5 is 30, plus 5 is 35. I add these all together, and I have 6, 15, 13, 14, 16, 8, 9, 10, 3, 8, 3. And then I'm going to add in my comma. So you have 380,656. If you like to do the lattice method, you have a 3-digit number by a 3-digit number, which means that you have to have 3 columns for the first 3-digit number and 3 rows. Now it's super duper important when they get to be this big that your lattice is really neat. We don't want to be racing through so we don't know where our diagonals go. So take your time and write your diagonals so they line up the corners as best as you can. And then we just go through our process. So I'll do the ones place in black. 2 times 6 is 12. 2 times 4 is 8. And 2 times 3 is 6. And I'm just going to switch colors just to help follow along here. 9 times 6 is 54. 9 times 4 is 36. And 9 times 3 is 27. Now we're going to switch to the hundreds place. And I have 5 times 6 is 30, 5 times 4 is 20, and 5 times 3 is 15. And now we can just add going down our diagonal of our lattice. 8 plus 7 is 15. 1 plus 2 is 3, plus 6 is 9, plus 2 is 11, plus 5 is 16. 1 plus 1 is 2, plus 4 is 6, 9, 10, carry the 1. 1 plus 5 is 6, plus 2 is 8, and then we have 3. And we count over 3, and again, just because it is easier to read, you should really rewrite your answer like this. And you'll see you got the exact same answer. On to the remembering side. The first 4, remember, acute is smaller than 90 degrees, obtuse is bigger than 90 degrees, and a right is exactly 90 degrees. It has a little square in the corner. But if we go down to the second section, this is where we have to go back to fractions. And in all of these, you'll notice that we have to find a common denominator. That's where we list our multiples. And the shortcut way is to list your multiples of the bigger number. So if I list my multiples of 5, I have 5, 10, 15, 20, 25. And then I can say, okay, does 2 go into 5? Nope. Does 2 go into 10? Yep. So I found my lowest common denominator. And now I say, okay, what did I do? Whatever you do to the numerator, you do to the denominator and vice versa. So I multiplied 5 times 2 and I get 10. So I need to multiply the numerator by 2 and I get 4. Same thing for the bottom number. I multiplied my denominator by 5. So I multiply my numerator by 5 and I get 5. Then I add these together and I get 9/10. And that's already in simplest form. If we look at the second one, number 6, I'm going to take my bigger number again and I'm going to list its count bys or multiples. 9, 9 times 2, 9 times 3, 9 times 4. I'm going to stop there because they're getting pretty high. Does 3 go into 9? Yep, I already found it. So my common denominator is 9. This 9 here didn't change, so the 1's not going to change. You multiplied it by 1 essentially. The 3, you multiplied by 3 to get to 9, so I need to multiply my numerator by 3 also, and I get 6. Now this time we're subtracting, so 6 minus 1 is 5. My denominator stays the same, and that's also in simplest form. I'm jumping down to number 13 now because of the mixed numbers and that we're going to have to borrow. If I look here, I already have common denominators, which is nice, but I can't subtract 1 minus 2 and get a whole number. So I need to borrow, and I'm borrowing 1 whole. And then remember, that's the same thing as 7/7. So I can add 7/7 and 1/7 and get 8/7. Or remember, the trick that we learned was that we take our numerator and our denominator and we add those and we change that number to that. And now when we subtract, we just have 6/7. And don't forget your whole number, you'll have 1 and 6/7. Number 14 says a sandbox is 6 feet long, 5 feet wide, and a ½ foot deep. What is the volume of the sandbox? Sorry that's blurry. I obviously didn't take a very good picture. If we look, we know that volume equals length times width times height. Length, width, height, or depth. So I am taking 6 times 5 times 1/2. Well, that gives me 30 times 1/2. When I multiply by a half, it's the same thing as dividing by 2. So I'm taking that 30 and I'm dividing by 2, and I'm going to move up here. And my volume is 15 feet cubed. You could also look at the half as being 0.5, and when you multiply 30 times 0.5, you would end up getting 15. But we haven't learned how to multiply by decimals yet, so this is a safer way, dividing by 2. The last one is just another volume problem because it's asking what the volume of the box is. The box is in the shape of a cube, which means each face of the box is a square, which means each edge of the square is exactly the same length. So our volume, the length, the width, and the height are all the same because it's a square. So I'm taking 16 and multiplying it by 4. Take 16 times 4, get 24. So I have 64 centimeters cubed.